All right, today we are looking at lesson 71. Okay, from chapter 8.3. Now we are looking at graphing your simple rational functions. So another quick sketch quiz. Okay, rational means it can be written as a fraction. So our parent function for our rational functions is simply y equals 1 over x. Okay, as usual, we're going to start with making an xy table. So if x is 1, then y is going to be 1 over 1, which is just 1. If x is 2, then y is 1 over 2. If x is 10, 1 over 10. All right, but what if x is 1/2? Then now what I've got is 1 divided by 1/2 from our previous lesson. Division by a fraction means multiply by the reciprocal. So that whole thing means divide. We're going to change it to be multiply by the reciprocal. So 1 times 2 over 1 will get us simply 2. Same idea. If x is 1/10, then y equals 1 divided by 1/10, which will actually turn out to be simply 10. But what is 1 divided by 0? Okay, if you stick in your calculator, it's going to give you an error, but that is simply undefined. You cannot divide by 0. Okay, continuing with the negatives now. What if x is -1? We get -1. What if x is -2? -1/2. If x is -10, -1/2 would get us -2. And if x is -1/10, we get -10. So with all of those in mind, let's plot our points. 1, 1, 2, 1/2, 7, 8, 9, 10, 1/10, 1/2, 2, 9, 10, 1/10, 10, -1, -1, -2, -1/2, -10, -1/10, -1/2, -2, and -1/10, -10. Now I skipped the 0 undefined on purpose, but at this point you should recognize, as we get ready to connect the dots, the reason 0 is undefined is because it is a asymptote. This graph's getting closer and closer to it, but never touching it. But you should also notice that the x-axis was also an asymptote. And we end up with a graph that looks like this. Now, the key things I want you to recognize is that our starting point was still the origin, in this case, for the parent function. So for the parent function, the starting point is the origin. Through that starting point, we have both a horizontal and a vertical asymptote. Now, there's only two whole number points that this goes through, and that is the point 1, 1 and the point -1, -1. That's all I'm really expecting you to plot. The rest, you just chase the asymptotes. Okay, the main parent function is in quadrants 1 and 3. Okay, so what are the equations of the asymptotes? Well, we have one of them is x equals 0. That's the equation of the y-axis. And we also had y equals 0, which happens to be the equation of the x-axis. Those are your two asymptotes. What is your domain? Okay, domain is the x's. So looking at this graph, what x values are represented by the graph? Is it everything? Is it all the reals? Well, it clearly goes forever to the left. That was a really ugly arrow, but definitely goes forever to the left. Does it go forever to the right? Definitely. But does it go everywhere in the middle? And the answer is no, because we have this vertical asymptote. So, in this case, the asymptote's at 0. So what is our domain? Well, our domain is all the x's such that x is smaller than 0, everything left of the y-axis, or everything greater than 0. Now, if you wrote it like that, that is 100% correct. Nothing wrong with that. But we're going to write a little bit shorter. Because, in other words, in this case, our domain is everything except when x is 0. So just simply say the set of all x's such that x does not equal 0. That's the easier way of writing our domain. Now what about the range? Same idea. It clearly goes up forever. It clearly goes down forever, but it is missing or not defined right there at that asymptote, which happens to be a y value of 0. So what is our range? The range is the set of all y's such that y does not equal 0. Now, it's important that you recognize that your domain and range are absolutely everything except the asymptotes. So there's a nice little correlation between those two. Alrighty, now with all that being said, let's flip the page, and now it's a quick sketch quiz. So number 2, y equals 1 over x plus 3. Okay, you should recognize that this is in the form of y equals 1 over x, so it's a rational function. What does the plus 3 do to the graph? Well, is the plus 3 grouped with the x? And while there are not, there are not parentheses, there's not any parentheses, is not, that's better. There is not any parentheses because the x plus 3 is all in the denominator, the parentheses are implied, understood. So yes, it is grouped with the x. And the plus 3 actually means go 3 to the left. So 3 to the left makes that right there our starting point. Now through the starting point, you have both a vertical and a horizontal asymptote. And then coming back here, if you remember, let's see, You went through the points 1, 1, and negative 1, negative 1. That's basically what I want you to know. So over here, from my starting point, I got the point 1, 1, and I got this point negative 1, negative 1. Trace your asymptote all 4 directions. Left, right, up, and down, chase the asymptotes. That's your quick sketch quiz. Next one, number 3. The plus 1 actually tells us to go left 1. The plus 2 here, not grouped with the x, tells us to go up and down, up 2. So we are going to go left 1, up 2. That is our starting point. Through that starting point, we have both a vertical and our horizontal asymptotes. And then it is going to go through the point 1, 1 and negative 1, negative 1 from that starting point. Chase your asymptotes. Again, I'm not real particular about how accurate you get with it, but don't let your graph do something like this. If it does something like that, it's clearly not chasing the asymptote. That will then be counted wrong. But as long as it's going in the general direction towards the asymptote, I'll give you some leeway. All right, number 4, y equals 3 over x. So how does that 3 change the graph? Well, it's the same thing as saying y equals 3 times 1 over x. So that's your parent function. What does the 3 in front do? The same thing the 3 in front does to every other function. It makes us get there 3 times as fast as normal. All right, now there are no shifts here, so that means the starting point is at the origin. Have our vertical and our horizontal asymptotes, but normally I would go through the point 1, 1. So it would be right 1, up 1, normally. Helps if you actually write the 1. Right 1, up 1 is what we normally do. So what does that 3 do to the graph? Doesn't do anything to the left, right. It adjusts the up and the down. So it's still going to be right 1, but now we're going to go up 3. So right 1, up 3. Now, this function, though, is a little bit different than normal. Y equals 3 over x. So if x is 1, you plug that in, plug 1 in for x, we get 3. Hence what we just plotted, the 0.13. But also from that graph, what if we let x be 3? So I get 3 over 3. What's my y value? 1. So not only do I get the 0.13, but I'm also going to get the 0.31. So whereas with the parent function, I only got 1 point in quadrant 1 per se. With that 3 there, it's going to give me 2 points. So right 1 up 3, but also right 3 up 1. Now we still have going in the quadrant 3 as well. Normally I would go left 1, down 1 to right there. That's not going to be right this time. This time we're still going to go left 1, but down 3. But also left 3, down 1. So in this case, we're going to get a couple of extra points. Still going to be chasing your asymptotes all 4 directions. And then the last one, number 5. That tells us to go 2 to the right and 3 up. So to the right, 3 up, there's our starting point. Through that starting point, I have a vertical and horizontal asymptotes. But what does that negative do to the graph? Okay, it flips it. So whereas normally I would go right 1, up 1, not this time. I'm still going to go right 1, but we're going to be flipped and go down 1. Normally I would go left 1, down 1. This time it's flipped, still left 1, but now we're going up 1. Ooh. Approach the asymptote, don't touch it. And there's our graph. But once again, it's just like your normal quick sketch quiz stuff. All the rules still apply. The only thing that changes is the parent function. All right, let's go back up to 2 and 3 and add in some stuff. So looking at 2 and 3, we'll start with 2. What are the equations of the asymptotes? Okay. With your asymptotes, let's do the vertical one first. The equation of a vertical line is always x equals. So this vertical line, it crosses the x-axis where? At -3. Your horizontal line, where does it cross the y-axis? At 0. So x equals -3 and y equals 0 are the equations of your two asymptotes. Now, what about the domain? Okay. Domain is the x's. It's the set of all x's except the asymptote. So x cannot equal -3. Your range, those are the y's. Y cannot be the asymptote. So y cannot equal 0. Other than that, it's everything else. All right, now number 3. Asymptotes. Again, vertical line. Vertical lines are in the form of x equals something. Where does it cross the x-axis? At -1. Horizontal lines are in the form of y equals. Where does it cross the y-axis? At 2. So those are your two asymptotes. Domain and range, if you've got your asymptotes, should be extremely easy. Domain is your x's, except the asymptote. Range will be the y's, except the asymptote. Okay, it is that simple. That is lesson 71, graphing your simple rational functions, a new quick sketch quiz graph.